These are the frequently asked questions for P4, day 1 and 2, and we're including these chapter opener problems here. Some people had some questions on. I apologize that I didn't get these in during my prep. The computer was not behaving itself and couldn't get it finished, so hopefully now it will behave itself. And the first one that somebody had asked about was using this information about the speed of light. And it says, if it takes 5 hours and 29 minutes for light to travel from the sun to Pluto, approximate the distance from the sun to Pluto. And what we have to work with is that we know this information. And that is that the speed of light is approximately 186,000 miles per second. So I'm looking at this information and right away I see an issue. They've given us this information in hours and minutes. So I have to get that into seconds if I'm going to use the 186,000 miles per second. So 5 hours, well, first let's get that into minutes. 5 times 60 would give us 300 minutes, but we also have to add that 29 on there. So we have 329 minutes. Now I need that in seconds, and 329 minutes times 60 seconds would give us 19,740 seconds. So using unit analysis, when I see they're giving me the time and I'm supposed to figure out the distance, I realize what I have right now is time. If I want that to cancel out and give me distance, then what I'm going to have to do is multiply this by something with miles on the top and seconds on the bottom so that seconds will cancel out. And that is this information right here. So I need to take 19,740 times 186,000 miles in 1 second so that those second pieces will drop out. And that gives me, let me scroll this up, 92,851,200 miles when I do that. So that is the first one that you had asked about on this page. The other one that somebody had asked about was number 8. And number 8, the instructions are to solve for y. So the first thing I would do is add 2y to both sides and get x squared plus 3y equals 3x. Then I would subtract x squared from both sides and get 3y equals a negative x squared plus 3x. And then finally divide both sides by 3. And y equals negative 1/3 x squared plus 1x. And now that is solved for y. So that takes care of the questions on the chapter opener problems. Now going to actual P4 information, we've got number 30. And number 30 says that we are to graph the linear equation on a grapher. We're going to use a graphing calculator. Choose a viewing window that shows the line intersecting both the x and y axes. So first thing we probably want to do is get that solved for y. That's going to mean subtracting 2100x from both sides. So 12y minus 2100x plus 3540, and then dividing everything by 12. So y equals, and then we could grab a calculator, negative 2100 divided by 12, and that will give you a negative 175x, and then 3540 divided by 12, and that gives us 295. So it says choose a viewing window that shows the line intersecting both the x and y axes. Well, for that, I would go back to the original and find my zeros. This is the one that I was talking about as the thumb method. And that's because the first thing that we would do is if we put a 0 in for x, this term would be gone. And so we would just need to figure out 3,540 divided by 12. Well, if that feels like deja vu, it's because we just did that, because that is the y-intercept. And then the second time through, we realize if we put the 0 in for y, this will be gone. So we'll take 3540 and we will divide that, forgot my x here, by 2100. And that gives us 1.6857, so 1.686. Now that determines our window because they asked us to make sure that we can see that x and y axis. So if it says graph it on a grapher, that's what we do. So let's get this in a calculator here, and hopefully we'll still be able to see that screen. So y equals negative 175, and one of the reasons that I had to wait to do this was because this graphing calculator was giving my computer all kinds of trouble. So I hope this works out this time. And if I hit zoom standard, we know we're not going to see anything that we need to see because the math, the algebra that we went through and did gave us our 0, 295, and 1.6860. So let's go in and manipulate that window. And we realize that our x's, well, if we're at 1.686, maybe we want to go from -1 to 2. And we'll do that by ones. But our y's, we know we have to go from 0 to 295, so I'll try -1 to 300. And graph. And we get a much better look there. You know, we can definitely see those x and y intercepts when we do that graph. So the algebra is what helped get us to that point. We could have fiddled around with the calculator for a long time, but what a waste of time to do that when you can just do the algebra and figure out where this needs to be. In exercises 33 through 36, there was a question about number 36, and what they're saying is, for the first ordered pair, we know 14 is the y value. For the second ordered pair, we know that 18 is the x value. And we're going to take this equation, put in the number that we know, and solve for the one that we don't. Well, y is 14, so 3x minus 2 times 14 equals 14. 3x minus 28 equals 14. Add the 28 to both sides. And 3x equals 42. Divide it by 3, and x is 14. Then for 18, for the second portion of this, we have 18 in the x position. So 3 times 18 minus 2y equals 14. And 3 times 18 will give us 54. And then we subtract 54 from both sides, and negative 2y equals negative 40. We divide by negative 2, and y will equal 20. So these problems are just an exercise in, do you recognize that they're giving you the x or the y value, and can you find the other one? So now we're at 40, well actually 38, I think you asked for both of those. Yep. All right, so 38 and 40 were asked for. And what this says is, in these exercises, they want us to find the values for y min, y max, and y scale that will make the graph of the line appear in the same viewing window as shown here. What they're asking us to do is mess with the y's in our calculator to end up going corner to corner on our window. And like you can see in the screen, we are supposed to leave the x's exactly as they are, but what we have to do is change the y's. So we go to the graphing calculator and we put in 5x. And if we hit zoom standard, it's not going to look like the window that we see over here. And that in no way has us graphing through the bottom left corner and the upper right. So we think, how do I change that? You know, what do I change when I'm trying to mess with the y's to make that go to the corners instead of where it's going now? So we just try something and we see whether or not it works if we don't know what we're doing. So we go down to the y's and we say, all right, you know what, negative 10 to 10 is not working. I can't see what I want to see. So maybe I'll try negative 25 to 25 by ones and see what happens. Oops. And that is another thing where I am pushing this faster than this calculator can take it. So window, Y min, negative 25. Yeah, the buttons are slow. So I keep pushing the buttons and it takes it a second to catch up. Okay, graph-wise. And I realized that moved my blue line a little bit. And it did help because what I'm hoping to do is continue to move the line this way. So I think about what I would have to do to the window to make that squish down, basically. And what I'm having to do is put in a lot more y's to make that squish happen. And I need to go back in and say, okay, that wasn't enough. And I'm going to be very careful to stop and wait for the calculator this time instead of assuming that it's keeping up with me. And I'm going to try negative 50 to 50 and see how close that is. And that appears to be right on. So now it's going corner to corner, bottom left, upper right, but I have an issue. Look at these intervals right here. They're not supposed to be all squished together like they are in my picture. So going by ones on the Y scale was not a good idea. You know, I can see all of those teeny little marks. So I go back into the window and I'm going to change that Y scale. I'll just try going by 5 since I take a look at it and think, okay, if I have 50 in my window and my window is normally negative 10 to 10, well, if I change this to 5, that should do what I need it to do. And I can see the tick marks, my intervals on the Y-axis look much more like the original did. So for this one, our Y min was negative 50, our Y max was positive 50, and our Y scale was going by 5s, and that made that work. So I try to think, all right, I had to squish this down to get it to move kind of clockwise, you know? So that's the thinking I need to use as I go on to the next one, which is Y equals 5/4 x. And what we're trying to figure out is what you should really change as far as a K value is. And the K value is what are we multiplying by out in front that would make this change happen. But for now, it's good enough that we can just get in there and work our graphing calculator because that's what they want us to do, is get a feel for it. So let's see, we've got parentheses, 5/4 and x. And we'll just try zoom 6. We know it's not going to work, but we just want to take a peek and see what it's like. So this one is a lot closer than that y equals 5x because the slope was considerably smaller. And I think about what I had to do last time with that window, and I realized this value of the y was 5. And I took it times 10 in order to get that 50 and negative 50. So now I look at this one and I think, you know what, that's 1.25. I wonder, because our window is negative 10 to 10, if it wouldn't be a good idea to try these as my Y min and my Y max. Just, following an instinct here that maybe these follow the same pattern. So I go into the window and I give it a try. So negative 12.5, positive 12.5, and while I'm there I think, you know what, in 38 the slope was 5 and I went by a Y scale of 5. This time the slope is 1.25. I think I'm going to give that a try and see what happens. And sure enough, there it is. And that was the pattern that they wanted us to see. It uses the fact that we want this to look like a negative 10 to 10 window. And we use that as basically a value to multiply by to make that happen. So the last thing to put on here would be Y scale, and that was 1.25. And it's all about manipulating what you're seeing in your viewing window is what they're getting at here. All right, my graphing calculator working much better this time, so hopefully I can make it through all of these. Bob Michaels purchased a house 8 years ago for $42,000. And it says that this year it was appraised at $67,500. And this is problem number 45. I realize that's kind of small print there, so hopefully you can make all of that out. It says a linear equation V equals MT plus B, where T is between 0 and 15, which means we need it to be time in years, and they want us to stick to a 15-year interval. That represents the value V of the house for 15 years after it was purchased. Determine M and B. Well, I noticed that in the 0 year, it was $42,000. But 8 years later, it was $67,500. Now I can use that to find a slope. So 67,500 minus 42,000 divided by 8 minus 0, which is 8. So let's run the numbers on that. 67,500 minus 42,000, and then divide that by 8, and that gives me a slope of 3,187.5. Well, they didn't want me to use y equals mx plus b. They said use v equals. So we have 3,187.5 times the time in years plus, and now my b value was right here, and that was 42,000, and I'm not going to be able to squish that and have it still be readable for you, so let me change this. So basically we're saying that from the data we have here, that the value of the house is going up by $3,187.5 every year. So with A, they just wanted us to determine M and B. M is 3,187.5 and B is 42,000. Now B says graph that equation and try to use the trace feature to estimate how many years after the purchase it would be 72,500. Well, I'm not going to use the trace feature unless it gives me a really, really nice situation. So I'll go into y equals, clear out what we had just a minute ago, and put in 3,187.5 x, because the calculator doesn't care whether or not it's an x or a y, plus 42,000. And obviously I have to change my window. Hang on. There we go. Have to change my window because we're talking about the value of a house. So window, they wanted this for the first 15 years, so we need 0 to 15. The house started out at the 42,000 mark, so I'll maybe go 40,000. And after 8 years, it was already up to in $60-some thousand. So maybe I'll try 120,000. And it really doesn't matter what I go by right now. I'd just rather it wasn't that nasty little 1.25. All right, so let's graph it. Y min, Y max, looks good. And, see, I got behind it again because it is not keeping up with me. I'm going to insert an X up here. I knew something was wrong when I got a straight line. Come on, there we go. And no matter how it works out this time, I'm definitely just going to keep going with the video. I had already tried since it was messing up before. I just got to slow down when I'm doing the graphing part. I apologize for that. It's going to take a while. All right, so now we see the line, and we hit trace, and we wanted to see when this was going to reach 72,500. And so I'm looking at the Y and waiting for it to get closer and closer to that 72,500. And it is really hard to read under the screen, but you can see it over here, so maybe look over there instead. All right, it just went over it. So we might say around 9.5 years. Or we go back into the Y equals, and we put in 72,500 and graph it, and then find the intersection. So second, trace, number 5, Blinky's all set. I'm going to move Blinky a little closer so he doesn't have to work so hard. Enter, enter, enter with your guess. And it is at about 9.6 years. So that would be the next piece to this. So for B, we put a sketch of what we saw when we graphed it. And actually it's not X and Y this time, it's T and V. And then in how many years after the purchase? Approximately 9.6 years after the purchase was when we had $72,500. All right, C. Write and solve an equation algebraically to determine how many years after purchase this house would be worth $74,000. Well, we were pretty close to that already, but let's go ahead and do it basically the faster way, especially with this calculator that I have on the smart board. So 74,000 equals 3,187.5 T plus 42,000. And we take the 74,000 and subtract the 42,000. And that would give us 32,000 equals 3,187.5 T. And then, of course, we would go ahead and divide by 3,187.5. And that gives you approximately 10 years, about 10.04 years. So really a good estimate there, about 10.04 years. Probably a little better estimate than we actually should be putting down. Because again, as time goes by, the equations become less and less accurate. D says determine how many years after purchase the house will be worth $80,250. So we're going to do the same thing, but with the $80,250. So that equals our 3187.5 T, and that was our y-intercept of 42,000. Subtract the 42,000 from both sides. So 80,250 minus 42,000 is 38,250. And then, not subtract, divide by 3,187.5. And that is exactly 12 years. Exactly 12 years. All right, finally done with that one. Now, let's see. Next one on the list was 47. A commercial jet airplane climbs at takeoff with a slope of 3/8. So rise over run is 3/8. Rise over run. How far in the horizontal direction will the airplane fly? Well, horizontal direction, that's the run. And how far in the horizontal direction will the airplane fly to reach an altitude of 12,000 feet above the takeoff point? That is the rise. So this is just a proportion. All we have to do is solve the proportion. So we'll cross multiply by taking 8 times 12,000. And that's going to be 96,000 equals 3x by cross multiplying. Divide by 3. And x equals 32,000. And this was in feet for number 47. So that one is just simply about slope. You know, rise over run. Make it work. Next up, number 51, Americans spending. Americans' personal consumption expenditures for several years from 1990 to 2007 in trillions of dollars are shown in the table. And it says the source, and again, they're just trying to pick out some real statistics for us here. And they give us those. A says write a linear equation for American spending Y in terms of the year X using these 2 points. We already talked in class about the example they gave us. That is just not a good idea, especially to use those 2 bottom left points. Very bad plan, but we're going to do it anyway. So they asked us to, that's what we do. We take the change in the Y's, 5 minus 3.8, and divide that by the change in the X's, 1995 minus 1990. So 5 minus 3.8 is going to give us 1.2, and then 1995 minus 1990 is, of course, 5 years, and we divide that, and our slope comes out to 0.24. Now, we're going to go ahead and use the point slope formula, and we just have to pick one of these 2 points, and I'm definitely going to pick the one that has the 5.0 and have a little nicer number there. So y minus 5 equals 0.24 times x minus 1995. So what we'll have to do is distribute that little 0.24, so we need 1995 times 0.24, and that's going to give us 478.8. And then we have to add 5 to both sides. So y will equal 0.24x. And if we add 5, basically because this is a negative, really what we're doing is just taking the 5 from that position. So 473.8. So that is part A to number 51. We've got a ways to go here. And this one I just realized why you thought this one was wrong. It's because the key is wrong. The book, again, has well, at least the solution manual has the wrong answer. It has it with a slope of 1.2. It doesn't have a slope of 1.2. It has a slope of 0.24. So that might be the reason that you needed this one. And B, use the equation to estimate Americans' expenditures in 2006. So we're going to go ahead and put a 2006 in here and see what we get. So 0.24 times 2006, and then we subtract 473.8, and that is 7.64. but we have to make sure that we're labeling this correctly. And that information was all in trillions of dollars. So dollar symbol and trillions back here. All right, part C. Use the equation in A to predict Americans' expenditures in 2010. Okay, this is getting a little old. We're going to put 2010 in for X. A lot of repetition here. 0.24 times 2010, and then we subtract the 473.8. So that will be $8.6 trillion right there. Now, D says superimpose a graph of the linear equation on a scatter plot of the data. So what we would want to do is just go ahead and graph those points that we see up there and then put our line over the top of it. What I am going to do is use the graphing calculator for that piece. So we go into, and this is all review from previous years. We could certainly draw this out by hand, but we've already done that in class. So I'm just clearing out the data that I already have in that first list. And what I'm going to do is put in the original data. So let me slide this over so that we can see all of that data. So our X's are those years, and we have 1990, 1995, 2000, 2005, 2006, 2007, and again I have to go incredibly slow with the smartboard information here. And then for the Y's we have 3.8, 5.0, 6.7, 8.7, 9.2, and 9.7. And I'm going to take a really quick look and make sure that those all went in properly. All right, second stat plot. I'm going to turn this on by going into number 1. And while the cursor is over the word on, I'm going to hit enter. And then I'm going to go down and pick just a dot plot, which is a scatter plot. And I check my next 2, and it says that it's going to use list 1 and list 2, and that's exactly what I want it to do. I want it to go ahead and graph that. But I have to change my window because my years went from 1990 to 2007. So let's see, I'll go from 1985 to 2010. And my Y values went from 3.8 to 9.7. So I will go from 3 to 10 by ones and see that scatter plot. Now the second part of this was that we wrote an equation for a line, and I want to make sure that you can see that while I'm punching it in. So that was way down here at the bottom. I better scroll that back up for you. Right here. So we go into Y equals, and we put in this information. Clear out what I had in there before. So 0.24x minus 473.8. And graph. So there comes our line. And just like the example we did in class, because they picked those 2 lower points, it's just getting way too far away from the actual data when you get to the upper right part of the screen. And that's because they didn't do this properly. You know, they didn't try to find a line that had about the same number of points above and below it, which we would do for linear regression. But again, this was by hand, and so we're saying, hey, pretty close for by hand work, you know? Because oftentimes when we calculate things by hand, we don't get near what we are supposed to have. So you just want to make a quick sketch in D of what we saw as far as those points went, where things seem to kind of curl up towards the end, and our line went like so. Next one you had for me was 53. The mid-year world population in millions for some of the years from 1980 to 2008 is shown in table P7. And it's got another source for us there, the census report. Let x equals 0 represent 1980, x equals 1 represent 1981, and so forth, and draw a scatter plot of the data. So if 1980 is 1, then 1981, or I'm sorry, if 1980 is 0, and 1981 is 1, well then 1990 would be 10, and 1995 would be 15 years later, 2000 would be 20 years later, 2007 would be 27 years later, and 2008 would be 28 years later. So we would want to go ahead and make a scatter plot with that data. And I think this time I'll just go ahead and make it along with what you probably did. So we've got to go to up to 28. And my screen is very, very small here. I'm not going to make it. I'm trying to keep everything on here as far as the visual goes, but I'm going to have to create this very, very small and just go by tubes. All right, then world population, I'm going to put the little jagged edge in the corner there and just do this really generally. 4,000, 5,000, 6,000, 7,000. And so this is our population in millions. And this is years since 1980. All right, draw a scatter plot of the data. We're not done because we need those points. At 0, it's 4,453, so maybe about there. Yeah, a little bit high. And then 10 is 5,282. 15 is at 5,691. 20, 6,085. 27 is at 6,628, and 28 is at 6,707. So there's a by hand scatter plot for A. It says use the 1980 and 2008 data to write a linear equation for the population Y in terms of the year X. So 1980 to 2008, we're going to be using these lines of information. I think that's an 8. That is just so hard to read. I hope that's what that is. All right, so we had our 0 year at 4453. And then 28 years later, 6707. So away we go. Slope, 6707 minus 4453 over 28 minus 0. So we've got 6707 minus 4453 comes out to 2,254, and all divided by 28 years. So our slope is 80.5. And our intercept is 4,453. So our equation, they did say to use y in terms of x this time. So that will be y equals 80.5x plus 4453. So now, if we're going to superimpose that on that graph of the scatter plot, we would go up to about 4,453, which is right here. And then we would use our slope to go up approximately 80.5. So if we just do a little quick rounding here and say, all right, this would be the same as, let's use 4,500. So if we say it's 4,500 and then we increase it by 80, we'd be at about 4,580. So up approximately 80.5 and over 1. So by hand, my graph is hugely off for the line from what we have up there. But again, it's going to happen sometimes when we go ahead and do that by hand. So now what I'm going to do is I'm going to back up and put it in the graphing calculator so you can see that a little more clearly. So the first thing I hit is second memory, number 4. I'm going to clear all of my lists in the stats. And then I will go into y equals and clear the equation that I had previously. Now, I go into stats, and I'm going to edit those statistics. Oops, wrong button. It did a second feature for me there. Second, quit. All right. Wow, it's having some issues. There we go. Okay, so there's our stats. Number 1. First list is going to be those values that we had created for the years based on the 0 year being 1980. So 1980 is the 0 year, 1990 is 10 years later, 1995 was 15 years later, 2000 was 20 years later, 2007 was 27 years later, and 2008 was 28 years later. And let's go ahead and put in 4453, enter, 5282, $56.91, 6,085, 6628, and 6707. All right, then in the y equals, we put the equation that we had come up with for this, which was 80.5x, and that was plus 4453. And the window. Well, we went from 0 to 28 for the years, so we'll try, I'm going to back that up and see a little bit of negative here. Give it a little bit of space. -1 to 30. And our y's went from 4453 to 6707, so maybe 4,400 to 6,800. And hit graph. My stat plots were still working. So definitely more accurate once I get rid of trying to graph the lines by hand. So if we can use the calculator, we want to do that. And I'd probably go back and try to fix this up a little bit with my green line and make it look more like it really should be. And that's because what we did was we used 2 points, one on each end of the line. And you get a better fit with that, but obviously not if you're going to do a bunch of it by hand. So then C says use the graph to predict the mid-year world population in 2010. All right, so what we could do is think, well, when would 2010 be? Well, that would be 30 years later. So let me go to the table feature, second table, and I'll just go until I get to 30. Unless it takes too long, in which case I'm going to go ahead and go into table set, which seems to be what I have to do. So second table set, and I'm going to change this to 30 years. And then go to my table. And there's the 30 years, and it would be 6,868 million. And let's see, what part was that for? That was for part C. Whew, those are a couple of whoppers, and because the calculator is moving so slowly here, that took quite a while. Hopefully the next ones will go much faster. And that, I believe, was the only one I put on that page. All right. Next page, you're up. In exercises 57 and 58, determine A and B so that the figure is a parallelogram. Well, to be a parallelogram, all the sides have to be parallel. So what I really need to figure out is, how far is it here? Oh, well, look at that. It's this length plus this length. Well, this length is 4, and this length is 2. If I move that over here, that's going to get me 6. So there's my x coordinate. But now my b coordinate is a little bit easier. And that's because these two are sitting on the same horizontal line. That has to be a 5. So for 57, in order for that to work out, A will have to be 6 and B will have to be 5. That is how it has to work. And I'm thinking it was the A that probably threw you, but once you think about the fact that it has to go right here, you can visually see it will have to be this portion plus this portion, which is 4 plus 2. So don't be afraid to redraw things on your paper so that you can write all over it and have it make more sense to you. 62 says the graph of any equation of the form ax plus by equals c, where a and b are not both 0, is always a line, and justify your answer. Well, in fact, that is standard form equation for a line. So the answer is yes, or I guess this was true or false. We're going to say yes, that's true. Now, how do we know that? Well, it says a and b are not 0. So if a is not 0 and b is, it would say ax equals c. And we would have an x to the first, which is linear. If a is 0 but b isn't, by would equal c. And that again is going to be linear because we could divide both sides by b, and that's actually a horizontal line. So that is linear. And then it says where they're both not 0. So we have covered both of those cases, and then we look at ax plus by equals c if neither one of them was 0, and we realize that is still an x to the first, which is also going to be linear. So that's why it's called linear. You know, that's the graph of a linear equation, and that is in standard form. Number 70. Last one up here. All right. So number 70 says we're going to connect algebra and geometry, and we're going to consider the semicircle of radius 5 centered at 0, 0 in this picture, as shown in the figure. Find an equation of the line tangent to the semicircle at the point 3, 4. Well, tangents are always perpendicular. So like it says, the hint is a line tangent to a circle is perpendicular to the radius at the point of tangency. So if we can figure out the slope of the red line, then we can use the opposite and reciprocal slope to get this. And it appears that that lands right on a grid point. So our slope, we'll use the point 3, 4 and 0, 1, 2, 3, 4, 5, 6. And that will get us what we need. So 6 minus 4 is 2, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Remember, it's slope, slope, find the slope, average rate of change. y2 minus y1 over x2 minus x1. So 6 minus 4 is 2, 0 minus 3 is negative 3. So the slope that we have right here is negative 2/3. But what we want is the slope of the perpendicular, which means the opposite and the reciprocal, which would give us a slope of 3/2. And then we use the point slope formula with the point that they gave us, which is they wanted us to use the point 3/4. So we're going to use that slope of 3/2, and we're going to use the point 3/4, and y minus 4 will equal 3/2 times x minus 3. So y minus 4 will equal 3/2 x minus 9/2, and then we would add 4 to both sides. And 4 is the same thing as 8/2. So we have a negative 9/2 plus 8/2, and that will be a negative 1/2. So that equation would be y equals 3/2 x minus 1/2. And I believe they said find an equation of the line tangent to the semicircle at the point, which means we could have stopped right here, because that is the form of an equation. That's just in point slope form that we see that. So what we had to do was figure out what the slope is and work from there. Problem where the solution manual answer does not match what it really is. So they must have changed this problem and not changed the solution manual, and that's probably the reason that somebody thought they were wrong on that one. So hopefully that takes care of all of those questions for you.